Welcome and good day everyone. So today we continue our lesson on learning outcome 5.2. State the work energy theorem. Alright, so this is work energy theorem. What is meant by work energy theorem is the net work done on the object is equal to the change in object's kinetic energy, or mathematically we write it as W is equal to delta K, where the net work done is equal to the change in kinetic energy. So this is the basic formula for work energy theorem, where this is F net darab dengan S cos theta, where theta is the angle between F and S. This is the change in kinetic energy. According to the work energy theorem, a moving object has kinetic energy because work was done to accelerate the object from rest to a speed of v. Alright, so we go to the work done by the force of gravity, or we can write it as Wg. The gravitational force is well-known force that can do positive or negative work. This figure below helps to show how the work can be determined. Okay, the object is falling downward. Okay, figure shows the gravity exerts force on the basketball. So the object is falling downward. So kita tengok kat sini, kita ada Wg is equal to Fs cos theta. W is work done by gravity, F is Fg. So Fg ini adalah kita punya mg lah. Okay, so Wg equal to mg. Okay, and then kita ada displacement. Displacement is from h naught, okay, ataupun h initial. This is our h naught, ketinggian kat sini. Okay, minus dengan h final. So maksudnya bola itu sampai ke sini. So ini kita ada kita punya displacement kita sebanyak s, di mana s ini adalah h naught minus dengan h f. Cos theta. Kenapa cos theta? Because the G, okay, direction of G and S is in Fg and S is in parallel. Okay, parallel. So we have 0 degree. So we have Wg is equal to mg h naught minus mg h final. So then we can say also that Wg is equal to delta U. Okay, this equation is valid for any path taken between initial and final heights. Thus, only the difference in the vertical distance can be considered when calculate the work done by gravity. Okay, only the difference in vertical distance, okay, considered when calculating the work done by gravity. Okay, so nanti kita akan tengok contoh-contoh soalan. Alright, so first 5.2c, apply the work energy theorem. Alright, so for exercise number 3, okay, in a smooth pulley system, a force is required to bring an object 5 kg, okay, the mass of the object is 5 kg, to the height of 20 meter at constant speed of 3 meter per second. And then v is 3 meter per second. Our acceleration is 0, okay, because the words constant speed is shown in figure determine the force. Alright, so here we label all the forces acting on the object. We have W and we have T. So here our T also equal to our F. Alright, so we have summation Fy is equal to ma. So because this is the constant speed, so then our acceleration is 0. Y equal to 0, so then we have T minus mg equal to 0, so T equal to mg. Okay, so F is equal to mg G, mass is 5, G is 9.81. So we have F is equal to stay 1 Newton. Okay, so this one we will just apply chapter 4 actually. Alright, so for the work done by the force, okay, so then we have the WF, work done by the force, is equal to Fs cos theta. Okay, work done by the force, so F is 49.1, S is 20, and then we have cos 180 degrees, because kita nak naikkan displacement ke atas, FG is downward, so we have 180 degrees. So WF equal to negative 982 joules. Alright, so then we have number 2. Okay, a stationary object of mass 3 kg is pulled upward by a constant force of magnitude 50 Newton. Determine the speed when it travels upward through distance of 4 meters. Okay, so we use the work. Okay, work done. Work done is equal to F net dot S cos theta. Okay, so then we have our F here, net di sini. So our F net is F minus dengan mg. Okay, net is 50 minus mg lah. Okay, so kat sini buat W equal to 50 minus mg darab dengan S. Okay, cos 0 degree. Okay, cos 0 degree because F and S is parallel each other. Okay, so work done equal to 50 mass is 3, 9.81 darab dengan S is 4, cos 0 degree. So the work done is 82.28 joules. Okay, 82.28 joules. But the question asks you to find the speed of the object. Okay, to find the speed of the object, we know that W is equal to delta K. Okay, W is equal to delta K when we use the work energy theorem. Okay, W is done. Okay, so half M V squared minus U squared. W is 82.28. Mass is 3 V squared. Okay, because U is 0, so our V is 7.41 meter per second. So that one is number 2. So 7.41 meter per second. Alright, so then for number 3, a block of mass 2 kg slides 0.751 meter down an inclined plane. The slopes downward at angle of 36.9. If the block starts from rest, calculate the final speed. Ignore the friction. Okay, so for this one you have to draw all the forces acting on the diagram first. Okay, so kat sini kita ada apa? This one we have mg cos 36.9 degree. This one is ag sin 36.9 degree. So we can ignore the friction. Right, so we use the work energy theorem where W is equal to delta K. W is F net, okay, dot S equal to delta K. So our F net is the only force is mg sin theta. Okay, to move the object downward. So mg sin 36.9 degrees S is 0.70 equal to delta K. Okay, so we calculate. So we have delta K equal to mg something equal to 0.70. So delta K is I tekan calculator dulu. Yes is 6.81 darab dengan sin 9 darab 0.750. So 88 and 8.835. So we know that delta K is half and V squared. Okay, equal to 888.35. Okay, saya tak tolak dengan U lah sebab dia kata start from rest kan. Okay, so kita nak cari V ke? Okay, nak cari V. So your V equal to so 2.97 meter per second. Okay. So settle number 3 and then we go to number 4. Okay, number 4 is the graph. So we have to find the the area on the graph. Okay, so number 4 here. Number 4 ni macam soalan nombor 9 soalan nombor 9 soap tu sama saja. Okay, so saya ajar dulu. An object of mass 2 kg moves along x-axis and is acted by the force F. Figure above shows F varies with distance travel. The speed of the object at 0 is 10 meter per second. Determine the speed of the object at 10 meters. Okay, so first of all, you have to find the work done. Okay, so macam mana kita nak cari work done? Kita tahu work done here. Okay, work done is the let's go to number 4. The object of mass 2 kilograms. Okay, 2 kilograms moves along the x-axis and is acted by a force. Figure shows how F varies with distance travel. The speed of the object at s0 is 10 meter per second. Determine the speed of the object at 10 meters. Okay, ingat when s0 u is 10 meter per second. So here you have to find the area on the graph. So kita cari dulu area on the graph. Okay, part pertama dengan part yang kedua. Okay, part 1 and part 2. So to find the area on the graph, okay, so F versus X is the area under graph. Area under graph ni juga lah kita punya work done. Okay, work done. So kita nak cari dulu area pertama dengan area yang kedua. Okay, so area yang pertama kita ada work done equal to half. Okay, 4 plus 6 darab dengan 10. So work done pada area number 1 tu adalah 50 joules. Okay, lepas tu area number 2, work done untuk case yang number 2 yang belah sini pula kita ada half, and then kita ada 10 plus minus 6 is 4 plus dengan 3. Okay, negative 5. So work done for number 2 is a negative 17.5 joule. Okay, so kita nak cari total lah. W total or W net equal to 50 minus 17.5 joule. So W total is 32.5 joules. Okay, tapi kita nak dapatkan speed of the object at 10 meters. Okay, kita nak dapatkan speed. So kita ada work done. Okay, work done is equal to delta K, Booth energy theorem. So W equal to half and V squared minus U squared. So work done is 32.5 equal to half. Our mass is 2. Our V kita tak tahu, U kita kosong lah. So then our velocity is 11.5 meter per second. Okay, so ni caranya macam mana nak dapatkan work done. Okay, and then find the velocity using work energy theorem. Okay, ingat W equal to delta K ni kita panggil dia sebagai work energy theorem. Alright, so kita tengok number B. The kinetic energy of the object at S equal to 6 meters. Okay, S equal to 6 meters. Alright, so kita nak dapatkan yang bahagian ini saja. Okay, S equal to 6 meters. Alright, so we go. Okay, so kita dapatkan dulu kita punya work. Work itu adalah area on the graph F versus S. Okay, so work done equal to half 4 plus 6 10, trapezium punya formula 50 joule. Okay, so area ini adalah 50 joules. Okay, sampai 6 tu sebab soalan tanya 6 saja. Alright, so we use the work energy theorem. So we have W equal to delta K. Okay, W equal to half MV minus U lah. Okay, so kat sini delta K is kita ada K final tolak dengan K initial lah. Okay, K final tolak dengan K initial. Okay, so work done is 50. K final is K final, kita punya K initial is half M U squared. Okay, so 50 equal to K final. Pada K final ni maksudnya masa S equal to 6 meters. Okay, K initial adalah pada S equal to 0 and U tadi 10. Okay, so K final tolak dengan mass kita is 2. Ni kan mass is 2. Okay, mass is 2 is good. So answer you have K final equal to 150 joules. Okay. Okay, so we continue our tutorial on number 10. Okay. A 60 kg box initially at rest slides 5 meter down a plane inclined 35 degrees with horizontal. The coefficient of penetration is 0.2, and then by using work energy theorem, calculate the final quick speed of the box. Alright, so kita cuba. Alright, so we have number 10. The mass of the box is 60 kg initially at rest. Okay, slide down the inclined plane which is 5 meters and have 35 degrees. Okay, so kita lukis lah. So this one is 35 degrees. So kita pilih box kita. Alright, so first we have to draw the forces acting on the block. Okay, we have one force, and then here we have mg cos 35 degree. Here we have mg sin 35 degree, and then we have fk. Alright, so here you have to using the work energy theorem. Okay, using work energy theorem, W delta k to find the speed. Okay, so first we have to find the work first. Okay, so macam mana kita cari work? Kita tahu work equal to F net dot S. Okay, so F net here we have mg sin 35 minus fk dot s. So what is mass 69.81 sin 35 minus fk is mu km darab dengan 5. Okay, so 69.81 sin 35 mu k is mu k given is 0.2. So 0.2 your n is your mg cos 35 mg cos 35. So then you calculate, you will have your work done is 1205.88 joule. Okay, so now kita dah dapat lah kita punya work done. Kita tahu using V𝕚𝕕𝕖 theorem, kita equal to delta k work done equal to half m a squared m u squared. So work done equal to work done 60 m squared. So 6.35 meter per second. Okay, so now we continue to number 12. Okay, figure shows a 15 kg block being pulled by 100 Newton force at the initial speed of 2 meter per second up an inclined plane. The block travels at a distance of 6.2 meter parallel to the inclined plane. The coefficient of kinetic friction is 0.14. By using the V𝕚𝕚𝕖 theorem, calculate the change in kinetic energy of the block. Alright, so here you have to find and you have to sketch or label on the forces acting on the block. So we have W, we have normal force, we have force of 100 Newton, and then you have this one is W cos 25 degrees, and then you have W sin 25 degrees, and you also have the friction. Okay, you also have the friction. Alright, so here tadi the work done by the force. Okay, work done by the force. Okay, pertama, so work done by the force equal to Fs cos theta. So work done by the force, F is 100, S is 6.2, cos 0 degree. So work done by the force is 6 joules. Okay, so kita ada kat sini work done by the force. Okay, work done by the force, work done by the satu kita ada work done by force, work done by gravity, dan work done by friction. Tu akan jadi tiga-tiga ni lah. Okay, tiga-tiga ni sebab kita nanti kita nak dapatkan kita punya delta K. Okay, so yang kedua kita akan cari work done by gravity. Okay, so WG equal to FG. Kita tengok tadi. Okay, ni kita boleh gunakan yang ni juga. Okay, walaupun kita punya kita punya apa dia namanya tu, force ataupun displacement ke sana. Okay, W is W sin 25 is against the motion, Right, so kita nak FG darab dengan S sin 150 bukan sin cos. Okay, kita punya MG is MG S kita 6.2. Okay, so dia boleh bagi S kita is S kita berapa? 15. This one is work done by gravity. Then number 2, you have to find the work done by friction. Is 0.14. Our head is W cos 25 and cos 25. Okay, 6.2. So the vibration is 1.1, so 6.10. Alright, so to find W total, we have to F and the friction equal to 18.67 joule. So we know that work done also equal to kinetic energy. So sama lah.